Hello. In this lecture, we will try to solve three problems. We need to find the fundamental period, or basically the period of given these three signals, and parallelly we have to check first of all whether these signals are periodic or not, and then we have to find the period. So we start with first x1t. x1t is defined as, for this problem, j into e raised to power j 10t. We know that x1t is complex exponential signal, so it is periodic. Now once it is periodic, we need to find period of this signal. We can break this, or we can expand this signal. From complex theory or from complex numbers, we know that e raised to power j pi by 2 is nothing but j, and e raised to power minus j pi by 2 is nothing but minus j. Okay, e raised to power j pi by 2 is j, e raised to minus j pi by 2 is minus of j. So here you can write this as e raised to power j 10t into e raised to power j pi by 2. Is it okay? Yes, we can write it. This is, we have replaced this j, and j is from here. Okay. Now what we need to do is, we need to find omega naught. So for this is a constant. So again you can write this into e raised to power j omega naught t plus phi, and we can do this e raised to power, what we have done basically, we have written j in terms of some phi because we have to include this j. Clear? So now you can write here j is nothing but 10t plus some phi is here pi by 2. And from our earlier lecture we know, once you know the complex exponential, the period is very simple. The period is, for complex exponential signal, period t naught is equal to 2 pi upon omega naught, and here omega naught is, you know, we can compare this is e raised to power j omega naught t, so this is omega naught, so t naught is equal to 2 pi upon omega naught. This is nothing but t pi upon 10, or it is pi by 5. So t naught is equal to pi by 5. Answer. x1t is periodic signal. It's a complex exponential signal, and period of this signal is pi by 5. Next is x2t, e raised to power minus 1 plus j t. Again we can write, we can expand, or we can simplify this in terms of standard form, that is e raised to power j omega t, e raised to power j 1 plus j t. We can write this in terms of this. How we are writing? Because if you can expand this, This is j plus j square multiplied by t. So this will give you jt plus j square t. J square t is again minus 1. So minus 1 plus jt. Clear? So we can write this in terms of j1 plus jt. Again, compare this with standard exponential. Standard exponential e raised to power j omega t. First of all, we should know whether it is a periodic signal or not periodic signal, or whether it is aperiodic signal. So we need to know what type of signal it is. So you can expand this, that is we can find out this is as e raised to power minus 1t multiplied by e raised to power jt. This from our problem number 1, here we know that it is a periodic signal. Exponential signals, complex exponential signals are periodic signal. Now what is this? This is exponentially decaying signal. And this is non-periodic. It is not periodic signal. Okay, non-periodic signal. So here we can see that a product of non-periodic and periodic will give you that x of t is non-periodic signal, and once it is non-periodic we are unable to find the period of this signal. So x of 2n is non-periodic. One is this. Parallelly, because we have expanded, there is one more reason. We can go in more detail. That is, you can, once we expand this, that is e raised to power minus t e raised to power j of t. Okay. Now once you compare these with standard complex exponential signal, that is compare it with e raised to power omega naught t. Okay, compare this by 1 plus jt. So this is your omega. So omega naught is 1 plus j. This is frequency. Okay, omega naught is frequency, or and here it is a complex number. One plus j is a complex number, and frequency of a signal can never be a complex number. can never be a complex number. So answer for second problem is yes. Problem number 2 is non-periodic signal. Come to third, that is x3 of t is equal to e raised to power j 7 pi n. Here it is not t, here should be n. Okay, again first step is simply compare it by e raised to power j omega n, and we know it is discrete signals. So for discrete signals, omega naught upon 2 pi, it is equal to m upon n, and n will give you period. Okay, so here by comparing we know that omega naught is equal to 7 pi. So 7 pi upon 2 pi is equal to 7 by 2. So what is the period? Period is not 7 by 2, period of this signal is 2, or fundamental period of is 2. Again note it down that here for continuous signal, single signal, fundamental time period is t naught, and this whole t naught is fundamental period. You don't have to check whether this ratio is rational number or not. But here once you get a discrete signal, first we should able to find out, or we should know, we should check whether this ratio is rational number or not. Once we get a ratio of integers, then n, that is denominator, will give you period. That is the important difference when you find out period of a continuous signal and period of a discrete signal. We should pay proper attention when try to find the period of discrete signal and period of continuous signal. That's a very basic difference we should keep in mind while finding period of signals. That's all for this lecture. Thank you.